Hi friends, welcome back. Today's topic for the introduction is Zero Defect Production Process. Now before we start our introduction, for the sake of new viewers, let me introduce myself. I am D.T. Jadhav, CEO of the company DTJ Manufacturing Excellence Support Private Limited, Pune, Maharashtra based company. We are in business of providing training, guidance, support, hand holding, critical maintenance services and low cost automation solutions to ancillaries in manufacturing MSMEs to improve their productivity, quality, cost and delivery. So let us come back to our core subject, zero defect production process. Now this point has become a demand of the situation because every company wants to grow, but how that growth will happen? We are in supply chain and our end customer is OEM. So we have to deliver as per his schedule. And perhaps we are supplying with zero defect. And customer may be happy on time delivery with zero defect supply. But what about his confidence in our way of working? So we have to work for gaining his confidence of our way of working. That's why this zero defect production process we have to adopt it. Secondly, at OEM's end, they also wanted their supply chain to be very lean and they are continuously monitoring our performance. And then they try to categorize who are the companies and suppliers who are in the category of lifetime source and which are the companies who are not improving their performance to their satisfaction. And those companies can go into the de-risking category. And naturally, if you wanted to grow, you have to remain in the good book of the customer. That is lifetime source category. Secondly, if we are producing with poor quality, and then cost of poor quality will be the cause for driving our profitability. From both the point of view, we have to adopt zero defect production process. Now, how to gain the customer's confidence? By way of product, on time delivery with zero defect supply. But if we are doing final inspection 100% and sorting out defective pieces and then ensuring zero defect supply, then perhaps customer will not be happy. So we have to adopt the production process which is capable of production with zero defect. And once we adopt this, the system to sustain that process and the culture of the shop floor people who are going to adopt the whole process. That will gain the customer confidence. And naturally, with this, our cost of poor quality will be eliminated and then our profitability also will be retained as per what we have targeted. Now, I have interacted with many CEOs of the company and there is always some thought process going in mind. They think when my engineers or designers, when they design the production process, they implemented it. Definitely it was for zero defect production. But when we actually start production on the same process, there are some defect getting generated. Means what? Either there is some kind of non-conformance, some kind of abnormality is still live and we are continuing with the production, or there is some indiscipline in terms of controlling the process, or there is a lack of awareness regarding 4MOT conditions. According to me, the most sustainable cause is lack of awareness of the people who are operating on that process on day-to-day basis. Now, how to achieve this? So, we have to follow some steps. First thing is we have to form a team of the front line in the shop floor. That team is frontline operators who are actually working on the machine, maintenance fitters who are maintaining the machine or equipment, tool room, tool fixture maintenance fitters who are maintaining the tooling, line inspectors who are controlling the process in day-to-day working, and frontline engineers. And this team we have to involve them while following certain activities to achieve zero defect production process. And over a period, we expect this team will become an autonomous team. Now, autonomous workforce and team, we have talked in detail in last session. Just for the sake of reference, how I look at this team as an autonomous team is they are well educated, well trained, experienced, skilled people who will be maintaining forever conditions of the production process, which will ensure a zero defect production process. And they are self-driven team. Whenever there are some abnormality related to 4M1T, without waiting for somebody's instructions, they are trying to set it right to ensure the zero defect production process. So this is in short about the autonomous workforce. So coming back to steps of zero defect production process, we have to involve the shop floor people, shop floor team to conduct operation by operation quality association matrix study, which in TPM called as a QA matrix. Now, what is this step? Study of the already happened defect and may happen defect. Then those defects we have to categorize into the A category, B category, and C category. Now, A category defect, perhaps one defect, one cause, it is easy to kill. This type of defect generates during the production process. Now C type defect, again one defect, one cause. This defect generates at the time of setup change, tool change, and this also is easy to kill. B type defect is a defect, one defect, many assignable causes. And for that, we have to train our people to follow fault tree analysis approach and study all the assignable causes and take corrective actions. Now, once we do this happen may happen defect study, and if we study along with this team, then we have to take corrective action in terms of quality guidance, FOCA, interlocking, and in some cases some checkpoints. So, like that, operation by operation, we have to kill happen defect as well as may happen defect. Then next step comes revisiting the 4M1T condition of the production process. Machine, man, material, method, and tooling. So we have to revisit the 4M1T conditions, redefine them, and whatever corrective actions we have taken while killing those defects, those also we need to include into the 4M1T conditions. This is the QM matrix study, quality maintenance matrix study. This also need to be carried out at operation level. Once this QM matrix is ready, then it becomes a reference document named as a IPO document, that is input process output control document. So operation level, this IPO document, once it is ready, then we have to educate our team how to have a 4M1T control with reference to this IPO document. Now if you look back at the IPO document, it will always have at least 30 points to be controlled in terms of 4M1T conditions. For easy understanding of the frontline people, we have to categorize them, which are the critical parameters which are referred into the IPO document, which can vary on day-to-day basis. Those critical points which can vary on day-to-day basis, there should be operational level one check sheet. And the other parameters which does not vary on day-to-day basis, those can be followed with reference to the PM schedule either it is equipment or tool fixture. So once this check sheet is ready, then the autonomous team once again will have to educate them for controlling the 4M conditions with reference to this check sheet. It is a production operator, it is a maintenance fitter, it is a tool maintenance fitter, it is a line inspector, and it is a front line engineer or supervisor. And the last step, if at all some defectives are getting generated during the production, then there has to be an operation level, machine level red bin discipline. Any non-conforming products or no good product, it has to be put into the red bin. At any cost, it should not go to the next operation. Now, coming back to how to define an autonomous team and autonomous workforce. If we look at DWM, daily work management of the production operator, machine operator, apart from his technical skills, he must follow some good practices like I do, I check. So every product being produced in his operation or in his machine, he will check it, ensure it okay, and then he will pass it on to the next operation. If at all he come across any defective product, he will just put it into the red bin. Secondly, I operate, I maintain. In TPM we call that autonomous maintenance. He has to follow cleaning, lubrication, inspection, retightening, and highlight the abnormalities and fix the abnormalities. Now he has to increase his scope for the abnormalities beyond equipment. So for a 1K abnormalities, all abnormalities he should be in position to check, and if at all there is abnormality, he should either fix it or get it fixed with the help of maintenance fitter, tool room fitter or anybody. Third point is adherence, strict adherence to the standard operating procedure. No shortcuts, no increase in speed and feed. So adherence to the standard operating procedure. Secondly, whatever Kaizens, Kokake, interlocks we have implemented in that operation, being first step, that is pneumatics, all those Kaizens, Kokake and interlocks has to remain live in all time. And then he has to follow tool change discipline also. So this is autonomous operator according to me. Next comes what is autonomous maintenance fitter or tool room fitter, tool fixture maintenance fitter. His job is to keep close watch on the abnormalities and daily while fixing the abnormalities. He did not wait for instruction from his seniors to fix the abnormalities. It should become a part of his daily routine. Then carrying out PM and DVM activity as per the schedule. Then ensuring all Kaizens, interlocks and Kokake are maintained in live and working condition. And very close eye on wear and tear. Naturally, when it comes to fixtures, when it comes to machine and equipment, there will be some sort of natural wear and tear. So these people have to keep a close watch and on the wear and tear, and they should replace those parts before it generates defect or breakdown. Now, what is the DWM of the line inspector? He has to ensure operation level control on the defective products. He has to ensure process is followed as per the SOP. He also has to keep a close eye on the abnormalities and get it fixed timely from the autonomous team members. He has to ensure that all interlock proprietary kaizens are all time working. There is no dead kaizens or there is no bypass of the proprietary and interlock. Then he has to be in touch with the final inspection and he should take the feedback. Whether that final inspection person is getting 100% of the job or if at all he is getting any defective products on his table. Then he has to ask himself two questions. Why the defective product has reached to the final inspection? Who did not follow the red bin discipline? Who did not arrest it at the operation level? And second question, Why at all this defective piece got generated? What is the non-conformance related to 4M1T? And then accordingly he has to set it right. That is the DWM of the line inspector. And then frontline engineer and supervisor, his daily work management will be operators are trained and they follow the daily work management. They are following adherence of the SOP. They are doing timely gauge, CLRIT and IPO control, 4A1T control with reference to IPO. The autonomous team is fixing the abnormality on time. All kaizers, Kokake interlocks are all time in working condition. He also has to ensure zero defect supply from the receiving inspection. If some of the operations are going on outside our company, then at receipt stage he has to ensure he get the defect free supply from the receiving inspection. And very important is whatever we have learned out of this process, everything should go in the form of visual controls at operation level. Whatever we wanted, we expect people to follow on day-to-day basis. It should go in the form of visual document at operation level. So that is the job of the frontline engineer. I am sure if we involve our shop floor team and then we develop them as an autonomous workforce and we follow the steps of QA matrix, IPO and IPO based foreign multi condition control, we can achieve zero defect production objective. Barring possibility of defect getting generated out of two, three causes. One is whenever power goes on and any cycle remain incomplete. At that time, that will be a defective piece. Second, at the time of setup change or tool change or while giving the offset, one or two pieces get defective. So such defectives operators has to arrest into the rear bin. Otherwise, during the production process, if we follow this zero defect production approach or process, we are in position to produce with zero defect. Now coming back to gaining the customer's confidence. We have to demonstrate the zero defect production process approach to the customer in the shop floor. And demonstration customer expects if that demonstration should happen from the frontline people. So whatever is the thought process at plant head level, whether that thought process has got percolated up to the last person in the company who is the production operator, customer will cross check whether he knows the zero defect production process, he knows the importance of 401T control, and whether he can contribute for that. So we have to demonstrate this zero defect production approach to the customer. Then he will gain the confidence that his company not only supplying with zero defect, but they are also producing with zero defect approach. And that we will gain our confidence from our customer. And ultimately, we will go into the his good books, that is lifetime source. And that will help us to gain more and more business from the customer. Second tangible benefit is if we are in position to maintain the flowability conditions, the production process will be smooth and that will definitely increase our production output from the same cell, same capacity. Thirdly, today we are doing the inspection, but the inspection is a cost, it is not the value. Over a period we can think of reducing the inspection, its frequency, manpower and work. Intangible benefit in this process, whatever our shop floor team, they can become an autonomous team and autonomous workforce. They can operate without somebody's support and without somebody's instructions. If That frontline team becomes an autonomous team. Then over a period we can reduce our overheads. We can follow lean structure. So on one side it is a lean organization, on other side it is a more business from the customer, from getting the customer confidence. So it is a vertical growth of any organization lean way. So this is the importance of the zero defect production process, and this is the demand of the situation. We have no option for that. We have to adopt it. My request is you please adopt this approach at least in one for one product in one manual model cell. Call the customer, demonstrate him zero defect production process, demonstrate him about our system, our approach, and our culture of the frontline people. I'm sure, I'm sure this will help us to improve our profitability by increasing into the sale. So, thank you very much. We'll again meet next time with a new topic of your concern. Meanwhile, if you like this video, please don't forget to subscribe it. Thank you very much. Let us meet next time.